Coulomb force. It explains the interaction force between two point charge, or according to it, one repulsive force acts between similar charge and attractive force acts between dissimilar charge. Second, the force of attraction or repulsion is directly proportional to the proportional to the product of magnitude of charge and inversely proportional to the square of distance between them. Third, the force acts along the line joining the two charges. Fourth, the force depends on the nature of the medium between the charge is placed. Thus, F proportional to Q1, Q2. Consider this is two point charge Q1 and Q2, which have distance R. If they are of same nature of charge, then there will be a repulsive force. If they are of opposite nature of charge, then will be attractive force. Now force will be given as F proportional to Q1 into Q2, proportional to 1 by R square, or proportional to 1 by K, or F proportional to Q1 Q2 by R square into K. Hence F equals to A into Q1 Q2 by KR square, where A is proportionality constant and K is the dielectric constant of the medium which characterize the property of medium. Here A is the proportionality constant. Here F equal to A into Q1 Q2 by K into R square. Here A proportionality constant, K is the dielectric constant of the medium which characterize the property of medium. Now, in CGS unit or ESU system, proportionality constant A equals to 1. So F equals to Q1 Q2 by K into R square in medium of dielectric constant K. Now in free space for CGS unit, in free space or vacuum, K equals to 1. Hence F equal to Q1 Q2 by R square in free space. This will be the formula in CGS unit for force. Okay. Now in SI system or MKS system, F equal to A into Q1 Q2 by K into R square in medium, and proportionally constant A here is 1 by 4 pi epsilon naught equals to 8.98 into 10 to the power 19 Newton meter square per coulomb square, or 9 into 10 to the power 9 Newton meter square per coulomb square. Hence, in SI system, the force will be given by F equal to 1 by 4 pi epsilon naught into K into Q1 Q2 by R square. This is formula for in medium when charge is placed in any medium. And epsilon equal to or this can be written as F equal to 1 by 4 pi epsilon Q1 Q2 by R square, where epsilon is the epsilon naught into K, that is epsilon equal to epsilon naught into K is called the permittivity of the medium. This is called permittivity of the medium. And here for medium, and here epsilon naught equal to 8.85 into 10 to the power minus 12 coulomb square by Newton meter square is called the absolute permittivity of the free space or vacuum. In vacuum or free space, the K value of K is equal to 1, and we write F naught for force in free space, then F0 equal or F naught equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This formula is for vacuum in SI unit, and epsilon naught will be given by 8.85 into 10 to the power minus 12 coulomb square by Newton square. Here F equal to 1 by 4 pi epsilon K Q1 Q2 by R square in medium. So F equal to 1 by 4 pi epsilon Q1 Q2 by r square. Here epsilon naught 8.85 into 10 to the power minus 12 coulomb square per meter is called absolute permittivity of free space or vacuum. In vacuum or free space, k equals to 1, and we write f naught for free space in force in free space, then f naught equal to 1 by 4 pi epsilon naught q1 q2 by r square. This formula is for vacuum. Now about k. About k, we have from epsilon is equal to epsilon naught into k, so k equal to epsilon by epsilon naught, and k is also written as epsilon r. K is also written as epsilon r. Hence dielectric constant of medium, this is called dielectric constant of medium. Hence dielectric constant of medium epsilon r equals to k equals to epsilon by epsilon naught, permittivity of medium divided by permittivity of free space. So dielectric constant of medium k equals to, or epsilon r equals to epsilon by epsilon naught, permittivity of medium divided by permittivity of free space. Epsilon r epsilon or k is a ratio and is unitless and dimensionless. Epsilon r or k is also known as relative permittivity of medium and a specific inductive capacity, SIC, a specific inductive capacity. So dielectric constant is also known as relative permittivity of medium or a specific inductive capacity. So it has three names. First is dielectric constant, second is relative permittivity of medium, third is a specific inductive capacity. Now dividing 1 by 2, equation 1 and 2, f by f naught equals to 1 by 4 pi epsilon naught k into q1 q2 by r square divided by 1 by pi epsilon naught q1 q2 by r square, or 1 by k. Or 1 by k equals to f by f naught. This implies k equals to f naught by f, or k equals to f naught by f. K equal to f naught by f, f naught by f. Force between two charge in vacuum, or force divided by force between two charge in medium. So k equals to f by f naught 1 by k. This implies k equal to f naught by f. So say now unit of epsilon or epsilon naught, we have, since epsilon equal to 1 by 4 pi f into q1 by q1 q2 by r square, hence unit of epsilon will be charge into charge, coulomb square, and this is constant, and this is Newton, force Newton, and meter square. So coulomb square by Newton meter square. Since epsilon naught equals to 1 by 4 pi kf into q1 q2 by r square, hence unit of epsilon naught again coulomb square by Newton meter square. Since k is a unitless, here from here you can also see that k is unitless, but f naught by f unit of f naught unit of both these four, so it will be unitless. K is unitless. Now dimension of epsilon naught, epsilon or epsilon naught. Epsilon naught or epsilon equals to q1 q2 by fr square dimensionally. So dimension q1 q into q by mlt minus 2 force, dimension of force, and r square l square. So we get m minus 1 l minus 3 t square q square. This is the dimension of in terms of MKSQ system, but in SI system will be m minus 1 L minus 3 T square, and Q square is A square T square. So m minus 1 L minus 3 T to the power 4 A square. This is in SI system. Now about Coulomb force. Coulomb force is a action reaction, that is force on one body is a action, then force on another body will be reaction. Example for F12, force on charge 1 due to 2, and force 2 1 is the force on charge 2 due to 1. That is, if this body is applying on this body force, then this body also, this particle also apply force on this, and which are and force are opposite in direction but same in magnitude, here shown. 2. Conservative force, that is work done in round trip is 0 by this force, that is delta. For example, this is shown a path where a charge particle, another charge particle is moving. So work done by here, this is a Q1 charge, and if we move this charge into this from flowing this path, then work done on this charge will be 0. That is delta WABC equal to 0, but delta WAB from delta WAB is not equal to 0. That is work done in a round trip is 0. Third, when two body interaction, that is this force acts between two body, that is the force between 2 point charge is independent of the presence or absence of other charge nearby. Two body interaction means that the force between these 2 point charge is independent of the presence or absence of other charge nearby. For example, here different charge is shown, for example Q1, Q2, Q2, Q3, Q4. Now if we consider the force between these two charges Q1 and Q2, then it is F12 given by, then it is will be independent of this and this charge. Similarly, force between these two charges will be independent of this charge and this charge, and similarly force between these two charges will be independent of this charge and this charge. So force between charge 1 and 2 is independent of nearby charge Q3 and Q4. Similarly, force between charge 1 and 4 is independent of nearly charge 2 and 3 etc. Next, 4, follow principle of superposition. According to this principle, if there are several charge and we have to find force due to several charge on a single charge, then the net force on this single charge will be sum by total charge, sum of force by total charge. For example, if we have to consider force on charge 1, then F1 vector net will be force on charge 1 due to 2, force on charge 1 due to 5, force on charge 3, force on charge 1 due to 4, dash force on charge due to n. So this principle is called superposition principle, that is F net equals to F12 vector plus F13 vector plus F14 vector dash F1 vector, where F12 is the force on 1 due to 2 charge 2. Similarly, F13 is the force on 1 due to charge 3, and F1n is the force on 1 due to nth charge. Next topic is our force in vector form. We have to write the force in vector form. Here it is shown a point A, a point B, point charge are placed, Q1 charge and Q2 charge at point B, Q1 charge at point A, and this distance is R, and AB direction is represented by vector R. Now force on 1 is because both charge is positive, so this force apply a force on this in this direction, and this force this charge apply a force on this point in this direction, which is shown. So we can write F21 vector equal to 1 by 4 pi epsilon naught Q1 Q2 by mode of RQ into R vector because we can see here r vector, this is the r vector in vector form. So 1 by 4 pi epsilon naught q1 q2 by mode of r vector into r square into r cap. We have to, if we write r vector, then we have to give here q, but if only so unit vector r cap, then we have to write only r square, mode of r square, where F21 is the force on 2D21 and r vector AB vector or r cap AB cap, that is unit vector along AB. Similarly, F12 force on 1D22 1 by 4 pi epsilon q1 q2 by mode of rq into minus of r vector, or minus 1 by 4 pi epsilon not q1 q2 by mode rq cube of mode r into r vector, or equals to 1 by 4 pi epsilon q1 q2 by cube of mode r vector ba vectors, or 1 by 4 pi epsilon not q1 q2 by mode of square of mode r into minus of r cap, because ba vector is if we take in unit vector term, then this will be minus r cap. Here if r cap is AB vector, then r cap will be AB cap and minus of r cap will be BA cap. Now position vector form, force on charge by the position vector form. Here it is shown. Consider this is point P1 and this is point P2, and here charge is Q1 and here is Q2. This is the position vector of charge Q1, that is R1 vector, and this is the R2 vector. Then delta R, this direction, that is this vector will be R2 minus R1 and written as R21, and this vector, if we take this direction and this vector from here to here, then will be R11 minus R2 R12 vector by vector addition rules. So we can write force on 1 due to 2, because force on 1 is a repulsive force, this direction is in this direction, so we have to write this vector. Okay, so 1 by 4 pi epsilon naught q1 q2 by mode of rq, mode of r12 का q into r12 vector. This is r1 minus r2 equal to r1 minus r2 r12, we have written r12, or equals 1 by 4 pi epsilon q2 q1 q2 by square of mode r12 vector equal to r12 cap. If unit vector term you write, this shows magnitude and this is the direction. Here again this shows magnitude, this is the direction. This is not the magnitude. Okay, because here we also written this in the form of vector, so we have to write it in magnitude into this form, this r1 vector as magnitude in direction. Then after the value will come out to be magnitude. Or this can be also written as 1 by epsilon q1 q2 by r1 minus r2 vector, which is r12 vector, which is r12 vector. This is shown. So r12 vector का whole cube r1 minus r2, and similarly 1 by 4 pi epsilon q1 q2 by mode of r1 minus r2 to the r cap 1. Here this represent magnitude, but here it is not representing magnitude, because we have to convert it into magnitude and direction, and then we have to take magnitude. But here only unit vector is written, so this whole will be a magnitude of force. So r1 cap again r1 minus r2, the mode of r1 minus r2, we can write here because here equals to r12 vector by mode of r12 and equals to r12 vector by r12. Next, for example, here shown in 3-dimensional, if point P1 is here, point P2 is there, then R1 vector can be written as x1 I cap plus y1 j cap plus z1 k cap into OP1 vector, and R2 vector x2 I cap y2 j cap plus z2 k cap OP vector. Similarly, Here we can write F21 vector 1 by 4 pi epsilon Q1 Q2 by cube of mod R2 minus R1 into R2 vector minus R1 vector, or in this form 1 by 4 pi epsilon naught Q1 Q2 by mod of R2 minus R1 का whole square into R21 cap. You always keep in mind that if here it is in vector, if this term is given, then you have to take here whole cube, and if it is written in unit vector form, then you have to take a square term there, or 1 by 4 pi epsilon naught Q1 Q2 by cube of mod R21 equal to mod vector R21 vector, because R21 vector or R2 vector minus R1 vector, or R21 cap equals to R21 vector by mod of R21 vector equals to R21 vector minus R1 vector by mod of R2 minus R1. Note, whenever we write force in vector form, the charge Q1 and Q2 should be placed with proper sign in calculation. Now F21 vector 1 by 4 by Q1 Q2 mod of R2 minus R1 to the whole cube into R2 minus R1 vector equals to minus 1 by 4 pi epsilon naught Q1 Q2 by mod of R2 minus R1 minus R2, or minus 1 by 4 pi epsilon Q1 Q2 R1 minus R2 to the whole cube R1 minus R2 equals to minus F1 vector, that is F21 vector equals to minus of F12 vector. So the Coulomb force is a action reaction force.